Hi there. There's a slim chance this video is going to work because it's a little bit setup that's not finished yet. But I've been working on this target-aligned heliostat. It's basically a mirror that you use to get light of the sun to a specific target. And the trick with this mirror is that it only has one axis. It only turns around one axis, but the mirror is mounted on that axis at a certain angle, so that it always divides the angle between where the sun comes from and where you want the light to go. So the sun moves around, let's say, a circular orbit through the sky, and you divide that angle with the mirror. You make sure that the axis of the mirror around which it turns is aligned with that with the axis of that circle, and then you only need one motor. So I've got a motor here, which is my gear motor that I use for everything at the moment. I have a low RPM. This is a 4 RPM motor. I mounted it directly before, but that of course is a little bit too fast. You have 15 seconds to make one turn, and I don't really think that's can be very precise. Now I've made this wooden wheel, as you can see, around the rim of which there's a wire that runs there, and the wire is, well, I have to show it like this. Wire is mounted to or connected to the axis of the motor, and as long as you have a counterweight, which is now my hand here, which pulls on the wire, even with the very small indentation that I made in the circle, this will basically allow the motor to pull the wire and thus turn the whole wheel. And the wire is connected to the wheel, so if the motor turns, it basically turns, but it turns, let's say the wire around the rim, it pulls it. So to see the work, I have my normally you would have like a 12-volt motor, but so in this case I have to pull it now because it's turning back towards where the weight is. And so this works pretty well. So the challenge is basically to keep the wire on the wheel, which has to do with the way you shape the wheel. Oh, the way you shape the wheel and the way the wire runs around the motor. So right now it's trying to run off. If you move it a little bit, it's back into the groove that's in the side of the wheel. But this is another way to very cheaply do this type of thing, because if you have to have, let's say wheels with, there's some obstacle there. If you have to buy all the parts, it's much more expensive than simply using a little bit of wood and a little bit of wire and a little bit of weight, counterweight. So I'm a big fan of this. Turning the other way is of course turning around voltage, power, and that's a little bit more secure because as the wire, let's say, runs onto the wheel, I've made a little bit here, a little nail to align it. But practically, the only thing I need to do is to find a good counterweight. Find a good way to mount this mirror, and then build the motor controller, which is in this case a two-way DC switch with some diodes, and then I can measure the angle, and that's what I'm working on with somebody else, because I'm not really that good a wizard with C programmable microcontrollers. But this angle turns it's simply attached to the mirror mount, which means that it will be possible to measure the exact angle here, and that is a very precise one. So, so as long as let's say the variation in the mounting of the mirror, if that's minimized, then this is a very good way to build a heliostat, I think, or to build, yeah, I think it's a heliostat. It's amazing how unintuitive the whole thought process about target-aligned heliostats is, because I still don't see it. I can see the idea that the Earth turns around and you turn the mirror the opposite direction, but for some reason I'm still wondering whether this will work or not. So we'll see once I have a counterweight and I mount this in a better way than I did now. And if we have the, let's say the Hall sensor position sensing, uh, then it's going to be a very interesting thing. The way I think about it is that you should do the sensing separate from the motor control, because you don't know what the motor control will be, what the types of motor will be. So it can be stepper motor or something else. And and of course there's also electrical distortion. If you have motor signals running in the same circuit as where your sensor signals are, which are serial data signals, there can be interference. Another thing to say, which is interesting, is that this is a geared motor. They are not very expensive. They can be very powerful, and as you can see, it's breaking the whole rig. So this is basically, if I put a counterweight on this, it's simply keeping it in position doesn't require any power. I think that with a stepper motor you will have to have power on it at all times, which is why you should, I think, why stepper motors are not really the thing to use. They are usually used with threaded wheels. So let's say you have something that runs over a thread, and then you have, of course, well, the multiplication of power that you get with a threaded rod that you run over, which breaks, which helps to brake and helps to prevent the motor from turning. But a stepper motor doesn't have any brakes. A geared motor has the same effect because it has the gears, and it will keep something in position. Run off the wheel here. Run off the wheel. Okay. Well, anyway, this is going to continue my work on this. And if you like these type of things and you want to support the development, for instance, of this position sensor platform, which will be well, relatively cheap for what it does. It's basically going to be a microcontroller, 2 Hall sensors for let's say rotary encoders, and of course a way to, let's say, understanding of how to use that easily. Actually, to interface it with a big XA microcontroller, which is basically basic programmable, and basically also to allow you to interface these devices with internet very easily. If you want to support that, then of course donate or send a message or invest or whatever you want to do. Maybe I should pre-sell the position sensors. The idea is that if once you have the position of these devices on the internet, available on websites, you can do any calculation, you can do any type of control with them. So if you have internet connection at home that is more or less constant, and you can have a little PC running on solar power or whatever, or in the future maybe a little Ethernet PC, then you can well, both control these devices from internet and get feedback from them, which might be a good way to I don't know, to increase the exposure of these type of applications and systems. So you have the Internet of Everything. People are talking about that. I think that if you have the Internet of all civilians and citizens, where they have a little bit, let's say, oversight and insight of what's going on in their environment, that could be very helpful. So surveillance is good as long as it's public. Then I think it can only be, let's say, a motor behind democracy. Especially when people are told to be empirical and not to listen too much to other people, but simply find their own facts and have their own experiences. But anyway, this is me with the target-aligned heliostat. We'll see whether it works, but it has to be finished. And thanks